Hello everyone, welcome back. In this session, we'll complete our Agent Network project and deploy it to CloudHub 2 following MuleSoft best practices. Let's get started. In last session, we have already tested our Flight MCP server and confirmed that it exposes 6 tools. Therefore, the actions defined in our travel planner broker must align with those tools. So I have now cleaned up the project and updated the travel planner broker.agent file. Here, you can see actions for all 6 capabilities: search airports, search flights, check seat availability, get flight details, get fare rules, and create flight hold. Each action now points to the correct MCP connection and uses the exact tool identifier advertised by the Flight MCP server. This is another area where MuleSoft Vibes can be extremely helpful. Now, let's scroll down to the planned trip orchestrator. MuleSoft Vibes has also updated the instructions and reasoning logic. Under the Actions section, you can see that all 6 MCP capabilities are now available to the orchestrator. This allows the LLM to select and invoke the correct tool based on the traveler's request. For this update, no changes were required in the Agent Network.yaml file. The changes were limited to the Travel Planner Broker.agent file, where we added and aligned the MCP actions and orchestration instructions. Because the broker asset has changed, we now need to publish the updated Agent Network assets to Anypoint Exchange using a new version. This time, I'll use the Anypoint Code Builder command to publish our updated Agent Network assets to Anypoint Exchange as version 1.0.1. Now, let's execute the command and wait for the publication process to complete. Great! The publication has completed successfully, and the updated Agent Network assets are now available in Anypoint Exchange as version 1.0.1. Deployment is a 2-step process. Let's start by setting up the Agent Network Gateway. Open the command palette and run the command. Set up Agent Network Gateways. First, select the appropriate business group. Next, select the dev environment and choose the CloudHub 2.0 private space that we prepared for this deployment. For the gateway configuration, I'll select Single Gateway, which is the recommended configuration. The command creates a single Managed Omni Gateway instance, which will govern both the inbound traffic reaching our travel planner broker and the outbound traffic from the agent network to services such as the Flight MCP Server and OpenAI. Now, let's continue and wait for the gateway provisioning process to complete. Perfect! The gateway setup has completed successfully. Let's open Anypoint Platform and verify the result. Here, you can see that the Managed Omni Gateway instance has been created and is running successfully. Our gateway infrastructure is now ready. In the next step, we'll deploy the Agent Network 2.0 project to CloudHub 2.0 using this gateway. Now, let's return to Anypoint Code Builder. I'll open the command palette and run Deploy Agent Network. First, I'll select the dev environment. It also provides the option to deploy to the CloudHub 2.0 shared space. However, because we prepared a private space for this project, I'll select my private space. The Managed Omni Gateway that we created earlier is automatically populated here. For this deployment, I'll continue with the single gateway configuration. This gateway will govern both inbound traffic to the travel planner broker and outbound traffic to services such as the Flight MCP Server and OpenAI. If your architecture requires stricter separation of inbound and outbound traffic, then select Separate Ingress and Egress Gateways. Now, I need to provide 2 runtime values. The first value is the endpoint URL of our deployed Flight MCP server. The second value is the OpenAI API key required by the LLM connection. Anypoint Code Builder will now deploy the broker and the required connection instances, associate them with our Managed Omni Gateway, and configure the related API and LLM proxy instances. Now, let's wait until every deployment step completes successfully. Perfect! Our Agent Network 2.0 project has been deployed successfully to CloudHub 2.0. In the deployment summary, we can verify that the project is referencing the published Exchange assets at version 1.0.1, including the Travel Planner Broker, Flights MCP Server, and OpenAI LLM provider definition. Now, let's validate everything that was created in Anypoint Platform. First, open Runtime Manager and navigate to Applications. Here, you can see that our Travel Planner Broker has been deployed successfully and is in the running state. If we open the application, the runtime type is shown as Agent Network. Under the application settings, we can see the runtime properties used by the broker to connect to the Flights MCP server and the OpenAI model through the LLM proxy. You'll notice that the broker application doesn't expose a direct public application endpoint. This is expected because external consumers must access the broker through the ingress endpoint managed by our Omni Gateway. This gateway managed URL becomes the secure entry point for all requests sent to the travel planner broker. Now, let's open API Manager and navigate to agents and tool instances. Here, we can see two managed instances, one for the travel planner broker and another for the Flights MCP server connection. Let's open the travel planner broker instance and review its policies. During deployment, MuleSoft automatically applies 4 policies to the broker: the A2A agent card policy, the tracing, header injection, and user context propagation policy. The A2A agent card policy ensures that the broker advertises the gateway managed public URL. The tracing policy enables end-to-end request visibility, while user context propagation extracts a user identifier from the authentication object and injects it as a request header for upstream consumption. Next, let's open the Flights MCP server instance. Here, 3 policies are applied automatically: MCP support, tracing, and agent connection telemetry. Together, these policies provide MCP protocol support, distributed traceability, and telemetry for communication between the broker and the MCP server. Now, navigate to the LLM proxies section. Here, you can see the OpenAI LLM proxy created for our agent network. The broker uses this governed proxy instead of connecting directly to OpenAI. The proxy also includes tracing and agent connection telemetry policies, giving us visibility into the broker's LLM interactions. Additional security, rate limiting, or AI governance policies can be applied based on enterprise requirements. Finally, let's open Anypoint Exchange. Here, we can see 4 published assets associated with our project: the Agent Network project asset, the Travel Planner broker, the Flights MCP server, and the OpenAI LLM provider definition. Remember, these assets are published to Exchange for discovery, versioning, and reuse, while their runtime instances are deployed and managed through CloudHub 2.0, Runtime Manager, and API Manager. Everything is now deployed, governed, and ready for validation. Next, we'll copy the Omni Gateway ingress URL and use Postman to test our travel planner broker end-to-end.